Good morning. I am Dr. A. Kalai Selvi. Today I present the topic heuristic functions. A heuristic function is a function that maps from problem state description to measures of desirability usually represented as numbers. Aspects of problem states are evaluated and the weights given to individual aspects are chosen in a way that the value of the heuristic function at a given node in the search process gives a good an estimate as a possible of whether the node is on the desired path to the solution. Sometimes a high value of heuristic function indicates a good position. Low value indicates an advantageous situation. No matter the wave function attempt to minimize it or to maximize it as appropriate. The heuristic function guides the search process in the most profitable direction by suggesting which path to follow first when more than one is available. Heuristic function estimates the true merit of each node in the search tree, the more direct solution process. Heuristic functions so good that definitely no search would be required. For many problems, the cost of computing the value of such a function would outweigh the effort in the search process. Compute the perfect heuristic function by doing a complete search from the node in the question and determine whether it leads to the good solution. Trade minus of balance between the cost of evaluating a heuristic function and saving a heuristic search time that the function provides. Some heuristic function used to define the control structure that guides the application of rules in the search process. The first one is skill climbing. It is the variant and a test in which feedback from the test procedure is used to help generator decide which direction to move in the space. The test function responds yes or no. Test function provides an estimate of how close a given state is to a goal state. The generate procedure that often the computation of the heuristic function is done. At most, no cost at the same time that the test for a solution is being performed. The algorithm for simple clay climbing is as follows. That is, first step, evaluate the initial state. That is, if it is also a goal state, then return it and quiet. Otherwise, continue with the initial state as a current state. Go to the next step, that is second step. In the second step, loop until a solution is found or there is no new operation left to be applied in the current state. In the next, select an operator for that has not yet been applied to the current state and apply it to produce a new state. Then the next one is evaluate the new state. How to evaluate it? That is, first, if it is a goal state, then return it and quiet. Suppose if it is not a goal state, but it is better than the current state, then make it the current state. If it is not better than the current state, then continue it in the loop. Algorithm for generate and test. Generate a possible solution for some problems. This means generating a particular point in the problem space. For others, it means generate a path from the start state. Test to see if this is actually a solution by comparing the chosen point or a end point of the chosen path to the set of acceptable goal state. If a solution has been found, then quit. Otherwise, generate this is continue this. Then next one is steepest and ascent hill climbing. This algorithm this is first evaluate the initial state. If it is also a goal state, then return it and quit it. Otherwise, continue with the initial state as a current state. Then continue the loop. If the loop continue the loop until a solution is found or until a complete iteration produces no change to the current state. Let successor be a state that is such that any possible successor of current state will be better than successor. For each operator that applies to the current state, do if the successor is better than current state, then set current state to the successor. Apply the operator and generate a new state. Then evaluate a new state. That is, if it is a goal state, then return it and quit. Suppose if it is not a goal state, compare it to the successor. If it is better than the successor to this state, if it is not better, leave the successor alone. If the successor is better than the current state, then set current state to the successor. Then the next algorithm, simulated algorithm is evaluate the initial state, then mark it as a current state. If it is not the goal state, then return it and quit. Otherwise, continue with the initial state as a current state. Initialize best state to the current state. If the initial state to the best state, returns it and quit it. Initialize according to annealing schedule. The next loop, that is loop is continued until a solution is obtained or until there is no new operator left to be applied in the current state. So next select and apply yet unapplied operator to produce a new state. Then evaluate a new state compute. That is computation is the value of current state minus the value of new state. That is delta I. If the new state is a goal state, then stop, or it is better than the current state, make it as a current state and record as a best state. If it is not better than the current state, then make it as a current state with probability B. Revise T according to the annealing schedule. Return best state as an answer. Thank you.